based on IEE standards. So, what is electrical machine safety based on IEE standards? It is ensuring reliability, efficiency, and worker safety. So, our group members is consists of 5 members. So, my name is Muhammad Zarif bin Mukhtar. So, for the introduction, what is electrical machine safety? Electrical machine safety is measured to prevent accidents and failures in electrical machines. And then, what is the role of IE standards? It is standards to guidelines to ensure safety, efficiency, and compliance. So, the key of IEE standards. For the first standards, which is IEE C67.20 series, which is switchgear safety. And the second is IEE 432013, is about insulation resistance testing. And after that, we have IEE 242 2001, grounding and fault protection. And then IEE 1584 2018 is about arc flash hazard analysis. IEE, and then we go to IEE 141. It's all about industrial and commercial or system safety. So, safety principle. First, we have ethical hazard prevention. In ethical hazard prevention, we have two IEE standard. It is proper grounding and regular insulation testing. Sorry. And for the arc flash protection, we have one, and we have two. First, hazard analysis, and the second, use of personal protective equipment, which is PPE. And for the system design and maintenance, we have also two, which is switchgear safety. Its standards called IEE C37.20. And the second is preventive maintenance practice. Okay, we go to the best practice. We look at the slide. So, for the first, follow logout or tag out, which is a lotto procedure. Lotto procedure. Okay, next, conduct regular safety training. Okay, next, perform predictive maintenance using IEE standards. And for the last, ensure compliance with local and international regulation. So, as we can look at our slide, I have concluded the spectrum industrial logout take out. So, first prepare, second notify, third turn off or shut down, four accelerate, fifth log out, sixth step out, 7 zero energy, 8 try out, 9 completion, and 10 re-energize. So, what the benefit of compliance? So, for the first, it improves worker safety. Second, it reduces downtime and equipment failure. And the last one, it's help compliance with legal and industry standards. Okay, and then I will go through to IEC 60034 Series 4 rotating electrical machine. For the rotating electrical machine, the standard we use is IEC 634 series. It's a set of international standard published by the International Electrotechnical Commission, IEC. These standards focus on rotating electrical machines, covering their performance, testing, construction, and more. Here's an overview of the key parts of the series. 4. We go to the general parts. First, IEC 60034/1. Its parts taught that rating and performance defines basic performance requirements such as voltage, frequency, insulation, and efficiency. For parts 2, for generalized part 2, IEC 634/2 is told us that method for determining losses and efficiency provides method for measuring and calculating efficiency and losses in rotating electrical machines. For the third general parts, which is IEC 634/3, is taught us that specific requirement for synchronous machines covers additional requirements specific to synchronized machines. Okay, for the first general parts, IEC 634/4 is taught us that methods for determining synchronized machine parameters focuses on test method for synchronous machines. And then we go IEC 634/5 talks about degrees of protection, IP code, defines enclosure protection against environmental factors, which is dust, water, and so on. For the sixth general parts, which is IEC 634/6, it taught us about method of cooling, IC code, specific cooling method for rotating machine. And for the last general parts, which is IEC 634/7, it taught us about type of construction and mounting height, which is IM code, and describes machine mounting arrangement and construction types. Okay, for the special parts. For the special parts, for rotating motor, we have IEC 634/8. It talks about terminal marking and direction of rotating. Defines the marking of in terminal and specifies the direction of rotation. Next, for the second special part is IEC 634/9. It taught us about noise limits, sets permissible noise level for machine. For the third special parts, IEC 634/12, it talks about starting performance for of squirrel cage motors, specifies starting characteristic for squirrel cage induction motors. And next, for the special part, we have IEC 634/14. It also taught us that mechanical vibration specific limits for mechanical vibration in rotating machines. And for the final special parts, we have IEC 734/18. For this last special parts, it explains what functional evaluation of installation system addresses testing and evaluation of ethical installation system. And we have a new edition, which is IEC 634/20. It talks us about efficiency classes for low voltage AC motors, introduces energy efficiency classifications such as IE1, IE2, IE3, and IE4.
Okay, my name is M.Iezzul. My matric card number is B08221057 4. Okay, and in my part, I will share to you navigating electrical machine safety. Okay, let's start. Okay, for this slide is the Foundation Occupational Safety and Health Administration (OSHA). So, what we know, OSHA scope is set to regulation for workplace safety, including electrical safety. This regulation cover a wide range of activities, from machine operation and maintenance to workplace design and emergency response. So, OSHA focus on preventing electrical accidents, fires, and injuries. Mm, for the standard of relevant, OSHA standard provides specific guideline for electrical safety in various settings, including general requirement for electrical safety in the workplace, such as using qualified personnel, proper grounding, and safety procedures. Specific guideline for working energized circuits, including lockout and takeout procedures and arc flash hazard analysis. Okay, so let's take a look for the next slide. For the next slide is NEC. What the meaning of NEC? NEC is National Electrical Code. Okay. The first point is foundation of electrical safety. The NEC provides a comprehensive set of requirements for electrical installation, including those for electrical machines. It covers everything from wiring methods to equipment installation, ensuring safe and efficient operation. For the second point is specific provision for machines. The NEC contains dedicated section articles focusing on electrical machines such as Article 430. 430 covers the installation of motors and generators, including wiring, overcurrent protection, and grounding. For the 600 article, covers electric cranes and hoist requirement, specific safety precaution for their operation. Okay. For the now, um, this slide show the understanding the purpose why standard matter. Okay, the first one, what we see is safety first. Okay, the second, prevent accidents, and the number three is to minimize risk, and the fourth, compliance and liability. Okay, NEC, NEC a deeper diff. NEC for DC machines. The point of NEC for DC machines. For the DC machines, the NEC provides specific requirement for DC machines, such as proper grounding and bonding to ensure safety, to adequate overcurrent protection to prevent overloads and short circuits, installation of controllers and enclosures to protect operators and the surrounding environment. Okay, NEC for AC machine meanings is the NEC that addresses AC machine installation, focusing on selecting appropriate conductors and wiring method based on machine capacity and operating condition for ensuring proper connection and termination to prevent loose connection and electrical hazard, specifying required safety device such as overcurrent protection and ground fault circuit interrupters GFCIs. Next slide is talk about international standards. Okay, the international standard is a global approach to safety. Okay, for the IEC, International Electrotechnical Commissions, the IEC set international standard electrical equipment, including electrical machines. This standard aim to ensure global compatibility and safety for products manufactured and used in different countries. For the ISO, ISO is stand for International Organization for Standardization. For ISO developed international standard for various fields, including safety. Their standard for electrical machine focus on design, testing, and operation, ensuring consistent safety across global markets. Okay, for the last, UL. UL is stand for Underwriters Laboratories. UL, a global safety science company, offers certification service based on IEC and other international standards. The certification verifies that electrical machines meet safety requirements, providing confidence to users and manufacturers. So the next slide is the key of requirement of electrical machine safety standard. Okay, the key requirement have 4 points. Okay, the first point is grounding, overcurrent protection, insulation, and enclosure design. For the grounding is effective, is crucial for safety. It provides a path for fault current to flow to ground, preventing dangerous electrical shocks. Proper grounding ensures a safe return path for electricity in case of a fault. For the next point is overcurrent protection. Overcurrent protection devices such as fuses and circuit breakers are essential for preventing overheating and fires. They automatically interrupt the flow of current when a fault occurs, limiting the risk of damage. For the insulation materials are used to separate electrical component and prevent accidental contact. Proper insulation prevents electrical shock and ensures safe operation by isolating live parts from grounded surface. And the last point is enclosures design. Enclosures play a vital role in safety, protecting operators and surrounding environment. They prevent accidental contact with hazardous components and ensure that machine operates safety. Okay, for the next slide is safety during operation and maintenance. The first one is lockout and tap. Lockout or take out. Lockout or take out procedures are critical for preventing accidental energization during maintenance. These procedures ensure that equipment is isolated and safe to work on, eliminating the risk of electrical shock. For the second, qualified personnel. Only qualified personnel should work on electrical machines. This ensures that they have the necessary knowledge, skills, and training to safely operate and maintain equipment. Okay, for the last point, at number three, regular inspection. Regular inspection of electrical machines are essential for identifying potential hazards. This inspection including checking for sign of wear, damage, or deterioration, allowing for timely repairs and maintenance. For the next slide, is beyond the basic emerging technologies and safety. Okay, emerging technologies and safety. At this slide have 3 points. The first point is automation and robotics. Number two, IoT and smart grid. Number three, renewable energy system. For the automation and robotic, advanced automation and robotic are increasing the industrial setting. These technologies pose unique challenge and opportunities for electrical safety. Require upgrade standard and practice. For the IoT smart grids, Internet of Things and smart grid transform energy system, creating new opportunities and challenges for electrical safety. This system require robust cybersecurity and intelligent safety protocols. So the RE source such as solar and wind power are growing rapidly. Integrating this system into the electrical grid requires careful attention to safety standard and interoperability. Okay, so let's go to moving forward. Embracing continuous improvement. In staying current with the latest standards and technologies is crucial. Regular review and updating of safety procedures are necessary to adapt to new technologies and evolving regulations. By embracing continuous improvement and working together, we can ensure a safer and more reliable electrical environment for everyone. Okay, thank you for hearing my slide. And then we continue to next part is soda.
Hi, my name is Anna Henry. My matrix number is B1124102303. Okay, I'm gonna discuss and present about essential legal requirements for operating electrical machine. Operating electrical machinery involve adhering to legal requirements to ensure worker safety, environmental protection, and proper machine use. Understanding this regulation is crucial for all those involved in the operation and maintenance of electrical machine. Worker first safety protocols. Number one is training and equipment. Companies must provide comprehensive training to workers on safe operating procedure, including the use of personal protective equipment (PPE) such as gloves, goggles, and insulated tools. Okay, number two is workplace safety. Regular inspection and maintenance of electrical system equipment and the work environment are essential to minimize risk of electrical shock, fire, and other hazards. Number three is emergency response. Clear and well-practiced emergency procedure, including lockout, takeout, first aid for electrical injuries, and procedure for fire suppression are critical in case of accident. Environmental regulation. Number one is waste management. For proper disposal of hazardous materials like oil, batteries, and electronic waste is essential to prevent environmental contamination. Number two is energy efficiency. Using energy efficient machine and implementing energy saving practice can reduce electricity consumption and minimize greenhouse gas emission. Number three is pollution control. Machine emitting pollutant into the air or water must meet regulatory standard through the use of filter, scrubbers, and other pollution control device. Next is certification and standard. Number one is UL, Underwriters Laboratories. UL certification ensure that electrical machine meet specific safety standard and are safe to use. Number two is ISO. It is International Organization for Standardization. ISO standard set international guidelines for electrical safety, performance, and environmental impact. Number 3 is other certification. Depending on the machine-specific application, other certification may be required, such as CE marking for product sold within the European Union. Specific safety requirement for DC and AC machine. For DC, direct current is grounding for high voltage system, especially for application with high power level. AC is alternating current. A dedicated grounding conductor is required for all AC machine to prevent electrical shock in case of a fault. Lockout or take-out procedure. Number 1 is isolation. The machine power source is disconnected from the power supply and all potential source of energy are shut off. Number 2 is lockout. A lock is placed on the power switch to prevent it from being accidentally turned on. Number 3 is take out. A tag is attached to the lock, clearly indicating the machine is under maintenance and should not be operated. Grounding requirement. For grounding requirement, the purpose is grounding provide a safe path for electricity to flow in case of a fault, preventing electrical shock or fire. For AC machine is a dedicated grounding conductor is typically required for all AC machine. For DC machine, grounding may be specific to certain DC system, especially those with high voltage component. Insulation standard. Number 1 is Class B insulation. This type of insulation is suitable for temperature up to 130 degrees and is commonly used in electrical motors, transformer, and other electrical equipment. Number 2 is Class F insulation. Class F insulation can withstand higher temperature up to 155 Celsius and is used for application requiring greater heat resistance. And the last one is other insulation classes. Different insulation classes exist to meet specific temperature and voltage requirement depending on the application and environment.
Assalamualaikum and salam sejahtera everyone. My name is M.Iezzul with metric number B0822100286. And in this part, I will walk you through how we apply safety and legal standards in the installation and operation of electrical machines. I will use a hypothetical scenario to demonstrate the process and outline the steps engineers must follow to ensure compliance. Firstly, imagine we are installing a new AC motor in a manufacturing facility. This motor powers a critical conveyor system, and it is our job as engineers to ensure the installation meets both international safety standards like IEC 60204 and local Malaysian regulations such as the Occupational Safety and Health Act 1994 and the Electricity Supply Act 1980. Let's go through the key steps. For the first step is pre-installation planning. Before any installation begins, the first step is pre-installation planning. This involves conducting a thorough risk assessment following ISO 12100 to identify potential hazards like electrical shocks or fire risks. We also verify that the machine design complies with relevant standards, including IEC 60034 for rotating electrical machines. Finally, we prepare all necessary documents such as operational manuals and certificates of conformity. The second step is installation preparations. We inspect the site to ensure it's suitable for the installation. This means checking voltage levels, grounding, and environmental conditions. All components like cables and protective devices must be sourced from certified suppliers to meet both international and local standards. In step 3, during installation, the actual installation, it is crucial to follow standard procedures. For example, we adhere to IEC 60364 for electrical installations, ensuring proper wiring, earthing, and insulations. We also conduct testing like insulation resistant tests to confirm everything is functioning as expected. For the step of post-installation verifications, once the installation is complete, we carry out a comprehensive inspection to verify compliance with safety regulations. This includes running the motor under load to test its performance. If everything checks out, we obtain certification from relevant authorities such as Suruhanjaya Tenaga. And the final step is operational and maintenance procedures. Finally, we prepare for ongoing operation and maintenance. This includes training operators and maintenance personnel on safe handling procedures and scheduling regular inspection to ensure the system remains compliant over time. In conclusion, by following these steps, we not only prevent hazards like electrical accidents and equipment failures, but also avoid legal and financial repercussions. Mostly importantly, we protect human life and ensure the long-term reliability of the installations.
Assalamualaikum, my name is Muhammad Afif Shakir bin Azmi, my matrix B0822102992. I will talk about importance of adherence. First, human safety. Electrical system and machines operate with high voltage and current, posing significant hazards to users and technicians. Following safety standards reduce the risk of electrical shock, burns, or fatalities. Second, equipment longevity. Components ensure machines are operate within their design specification, preventing premature wear or failure. Third, legal and financial liability. Non-compliance can lead to legal action, fines, and compensation claims. Last, environmental protection. Standards often address sustainable and the prevention of environmental harm, ensuring the electrical system operate efficiently with minimal environmental impact. Next is risk of non-compliance. Overload circuits occur when they are used beyond their rate capacity, causing excessive heat that can melt insulation and potentially ignite electrical fire, such as when an overload power, street spark and blaze, endangering property and life. Second, damaged equipment. Operating machinery without proper maintenance or exceeding its design limit can damage equipment such as a faulty transformer, causing widespread power outage that disrupt critical operation. The last one is electrical fire, caused by spark from arcing, faulty connection, or overhead component, can lead to the destruction of property, injuries, or fatalities, as seen when a neglect switchgear fault escalates into a widespread industrial fire. The conclusion is adherence to safety standard and legal requirement is indispensable in electrical engineering to ensure that the safe operation of electrical machines, protect human life, safeguard property, and maintain compliance with legal obligations. The implementation of standards like IEE, IEC 60034, OSHA, and NEC, coupled with a robust understanding of legal requirements, help mitigate risks such as electrical fire, equipment damage, and workplace hazards. Engineers must adopt a proactive approach to compliance, ensuring that every phase of electrical machine operation from installation to maintenance aligns with the prescribed standards and regulations. Ultimately, this not only minimizes risk but also fosters a culture of safety and accountability in the field. That's all for me. Thank you.